Good morning. It is Friday, October 24th, 2025. It has been quite the challenging forecast to track down exactly where Melissa is and where it's headed over the next several days here. Looking at the zoomed out view here on the satellite imagery, we can clearly see that Melissa is clearly located here in the Central Caribbean. Nothing different from a couple of days ago where it is pretty much stationary. Sometimes it is moving erratically towards the west, to the north, to the south, to the east. And that's pretty much what is happening tonight still, where we are still seeing center relocations underneath this deeper pocket of convection, all thanks to the vertical wind shear that the system is still facing here that is coming out of the west at around 25 miles an hour. And when we take a closer zoomed in view here on the infrared satellite imagery, we can clearly see with what the system is currently exhibiting, not only that vertical wind shear that we just talked about that is around 20 knots out of the westerly direction, but we're also seeing that drier air that I will show you here in a moment on the water vapor imagery that is encroaching in out of the northwesterly direction, undercutting the cirrus outflow layer that you can clearly see here. See these cirrus clouds that are radiating outward? One might mistake that as a favorable environment, where in definition that would otherwise mean a favorable environment with a lot of moisture. But in this case of Melissa, there is vertical wind shear underneath this cirrus canopy that is ruining whatever inner core structure is trying to develop within. And when we zoom out here on the water vapor satellite imagery here across the entire Caribbean basin, we can see where all of that drier air is clearly indicated here. All of this dark brown color here on your screen indicates very, very dry tropospheric air above 850 millibars ingesting into whatever inner core structure is trying to get established here with Melissa. And some of this drier air is even encroaching to the south of the system and trying to wrap all the way around here. And that is why we have had these bursts of thunderstorm activity around Melissa tonight. And also that vertical wind shear underneath is helping that out nicely, keeping persistent convection from going and helping to lower the surface pressures at the very center. So with that being said, the biggest challenge ahead for Tropical Storm Melissa over the next 5 to 7 days is where is it headed? Who's going to get the worst impacts and how strong is this going to get? We're first going to look at our track guidance forecast here on the European Ensemble model, all 51 different members blended into a model here for us to give us the most likely outcome here at the 500 millibar height anomaly sigma. And so what we have here simply that has been constant in past model runs is there is two ridges of high pressure that have been the biggest story driving why the system is in no hurry to get out of harm's way here. We have this deep layer ridge of high pressure nosing in across the Gulf into the Florida Straits. We have another high pressure center located over the Eastern Caribbean, over the Lesser and Greater Antilles. We have a trough up here like I've been talking about in prior discussions that is moving out of the eastern seaboard into the northwestern Atlantic, leaving behind this weakness in the subtropical ridge here. But the problem is the system is being mired underneath these two ridges of high pressure. So we have a high here. Again, we talked about these two highs. And the problem with these two high pressures is they're opposing flow channeling, okay? So this other high pressure here over Florida, you're getting this south or this northeasterly flow trying to yank the system further to the southwest. That's why the system is moving erratically right now, trying to decide on which flow to go with. We have another river of air coming in out of the south around this other subtropical ridge over the far eastern Caribbean and over the western main development region. So you get these opposing flows, they cancel each other out, and the ending result is the system is not moving at all, or it is moving very slowly and erratically in different directions, and we cannot really pinpoint exactly where this is headed in real time right now. Sometimes it moves north a couple of miles an hour, sometimes it moves south, sometimes it moves east, and sometimes it kind of drifts towards the west right now. And so until we get a more permanent, if I can not tongue twist my words here, until we get a more solidified track here off to the northwest or towards the west, we really don't know exactly how close this is going to get to Jamaica. So I'm going to roll that through in today's update here in the ensemble, and we can clearly see how this all evolves here over the next 48 hours. So for the latter part of the weekend here, by Saturday night into Sunday morning, we can see we have this subtropical ridge that noses in to the north of the system. This is very critical for the turning point of Melissa. If Melissa can remain weak, which we'll talk about with the intensity guidance, as it is mired underneath the subtropical ridge, that's why most of the solutions have this moving generally westward to the south of Jamaica, as this subtropical ridge here is not much of an influence at yanking this out to sea, out of the Caribbean in a hurry. And so as we go forward here into Sunday, we can see this subtropical ridge is well firmly established on Sunday to the north of the system. You can see a little bit of a thin tongue here of ridge that is over the Florida Straits, extending out into the central Atlantic, into the southwestern Atlantic over the Bahamas, not allowing the system to get ushered northward immediately here. Now, this trough over here across the high plains that is going to produce a 5% risk for tornadoes, this is going to be ushered to the east with time, helping to erode this flank of the ridge here and allowing a lane of opportunity for this system to then turn out to the north and back towards the northeast to the west of Jamaica. And you'll see this, how it all evolves here on the European ensemble. You can see this trough is well modeled right now over the southeastern United States, and we can see prior model runs here over the last few cycles. We can see how this trough is actually a little stronger with each subsequent run. But the thing is, our system is a little further west, but there is still enough of a pull and a yank on this trough here and a weakness between the two, where most of the members eventually do turn this out over the Central Caribbean and then out into the Bahamas at around 4 to 5 days. And that seems to be the case in latest model runs from the European ensemble. Now, the GFS or the GEFS ensemble, which is an entirely different evolution here, shows a pattern very similar, but there are some subtle changes that we need to talk about. So putting this again into motion, we can see, first of all, the system generally drifting off towards the northwest here. But the problem here is this ridge is not being sampled by the model as strong. And so what ends up happening here is the system really slows down and it doesn't get as far west as what the European ensemble indicates. And if we actually look at the 3-day forecast, actually as we go back here to 48 hours, day 2, that would be Saturday afternoon into the evening hours of the 25th and the 26th of October. Keep an eye on this ridge here on the GEFS ensemble. And when we look back here on the same time frame here, since these are both 0Z outputs, we can see that the European model has a stronger ridge to the north of the system versus the GEFS ensemble has a weaker ridge. And that's the difference that it makes between a system that pretty much moves to the east of Jamaica or directly over Jamaica versus the European ensemble solution that keeps this a little further west a little longer before the turn to the northeast actually occurs. It's that subtle difference that models are not handling very well. And until we get a better understanding exactly how the pattern evolutes, we will have to hopefully get some upper level recon data from the G4 aircraft that should hopefully sample the northern side of the system to better initialize where the ridge actually is, how strong it is, then to feed that data into the models. And hopefully that will occur hopefully soon rather than later, because this is a very complicated situation. So on the European ensemble, again, we talked about the 500 millibar chart, but we can just see how different this actually is. I mean, we're talking 2.5 to 3 days here, and we have a very big spread in our track guidance, something that is still into Nicaragua and Honduras. That's probably a southerly outlier scenario, so we can throw that out of the box here and throw it in the trash. And some of the ensemble members, only a couple of them, still bring this into far western Hispaniola in about 3 days. So we have a huge track spread here from something that looks more like this, right? And some of the ensemble members are a little too far west within the initial conditions. So that's probably why they are too far to the west to begin with a solution more like this. So if you keep an eye on the northeastern part of this ellipse of ensemble models. Keep an eye on that. We can see that most of those members do bring this just to the south, or if not directly over Jamaica, in about 3 to 4 days, perhaps, as a formidable hurricane, perhaps with winds that are at least 115 to about 130 miles an hour. But again, the southern end of this does not look to verify, in my opinion, because I do believe that some of the members initialized a little bit too far west than what is currently being realized. But nonetheless, though, most of the members do bring this directly over Jamaica and just to the west of Jamaica over the Cayman Islands. So the Cayman Islands needs to be watching this system very closely over the course of the next 5 days. And you can just see how uncertain the forecast actually is, a cloud of possible outcomes. That's a big spread in about 5 days, and hopefully this narrows down in subsequent model runs once we get a more solidified vortex that it remains very disheveled at the moment. And therefore, when we take a look at our latest track guidance forecast from the 0Z initialization here on most of our hurricane models and global deterministic modeling, we can clearly see here that there is still a decent amount of spread in the track guidance here. There is not much narrowing here, and I really hope this changes over the next few model cycles. But sadly enough, until this gets on the move and until we get a more well-established motion on this system, this is going to be moving all over the place, and it could take a couple of days before we see a narrowing here closer to Jamaica. But I want to make it clear in this video, please do not use this map to make decisions. Please seek official info, especially from the National Hurricane Center, since they are clearly the experts at knowing what they're doing. Please visit national nhc.noaa.gov, something like that. There will be a link in the description below this video leading to that. But you can see all the track guidance is right over on top of Jamaica. So Jamaica needs to be watching this system extremely closely, as devastating impacts to life and property are certainly a possibility. That from strong winds to very heavy rainfall that can last days on end. And it's not just from Tropical Tidbits website indicating this. We are also seeing this from our latest Google DeepMind AI modeling forecast, which is an artificial intelligence model that uses machine learning technology to basically forecast many different scenarios here on what may happen and exactly where this is headed. And we still have a big round of possibilities here. Some tracks going just to the east of Jamaica, and many tracks going as far to the west here as perhaps close to the Cayman Islands and just to the west of Jamaica as well. So again, we do not know right now for a 100% certain if this is or won't make landfall over Jamaica directly. But it seems like most of the ensemble model guidance in this package has shifted a little bit further to the west here. And you can see a big clustering of ensembles here, pretty much right smack dab on the far western side of Jamaica and just off the coast here. Also impacting the eastern half of Cuba and then eventually over the central portion there of the Bahama Islands in about 6 to 7 days. Again, even the European model, as we discussed earlier on the Weather Bell website, again, there is a lot of uncertainty exactly where this is going right now, but I would assume that these westernmost outliers here that are furthest to the south can be thrown out the window just because of where it initializes the system. Getting my words straight here, having a hard time with that this morning. But the system really goes too far west before making the turn. So I'm really narrowing down somewhere over here closer to Jamaica because of what we're currently seeing right now. This little turn to the northeast and then eventually yanking it a little, drifting it westward before the turn eventually happens back to the northeast. Kind of this whole zigzag pattern, kind of a backwards looking Z in the alphabet of what we're seeing. Even the generational model has shifted a little bit further west in this model cycle, still indicating that there are plenty of members over Jamaica and just to the west with very intense outcomes over the Cayman Islands and again over the eastern half of Cuba and over the central portion there of the Bahamas, again in about 6 to 7 days. So anybody living on Cuba in the central portion and the Bahamas needs to be paying close attention to this system, as this could emerge off of Cuba quite intense. And then lastly, on our ensemble model suite here from the GEFS, you can clearly see they are going pretty crazy with this, with the easternmost outliers still directly into the Tiburon coast of Haiti, along the Haitian Peninsula there, with most of the members still aiming directly towards Jamaica and far eastern Cuba into the Turks and Caicos Islands of the Bahamas, in about, again, that 6 to 7 day time frame. So now, since we talked about the latest track guidance forecasts for most of our ensemble models and our deterministic models, it's a good idea that we also focus on the intensity guidance forecast as well, because there is a great deal of uncertainty exactly how strong Melissa is going to get, and that is largely dependent on exactly where it's located right now. How close does it get to Jamaica? Because yes, if it encounters land areas like Jamaica with the tall mountains, that's going to disrupt the circulation and vortex and allow the system to be much weaker than if it is south of Jamaica before it makes a turn to the northeast, where that solution is far more intense than it saying going further to the east of Jamaica, if that makes sense. We can see this on the GFS model, and the reason why I want to show you all the GFS model is, for one thing, this is an outlier, so we can't really put a lot of stake into this because it is known for its convective feedback that is very strongly biased in this situation. And that's why it really blows up the system very quickly and erratically, and it tries to yank the system up further to the northeast, still directly towards the central portion of the Dominican Republic and Hispaniola. And you can see this here, where it thinks that the circulation is going to be much further to the south and much further to the east than what is actually in reality. So I'm not really going to spend a whole lot of time on the GFS here just because it is a huge outlier in this case, but you can clearly see that the system is much further to the east than what is being seen in reality right now, where the system is more likely over here. And so it really, again, with that convective biased feedback that the model is ingesting with repeated run right now, and it has not changed by much, this really blows up, but it is much further to the east here, and it really does not move at all and doesn't even move to the west at all, because a deeper vortex, in this case, with a weaker subtropical ridge that we mentioned towards the beginning of the video, not as strong to the north, the system is going to be able to get ushered very gradually to the north. But we have seen some slowing and some westward trends with the GFS. For an example, if we look at the 18Z run, we can see it was a little further to the west and a little stronger, but the previous run was much further to the east, and the run before that was even a little further to the east. So we have seen some corrections with the GFS, but not enough to say that the GFS is more reliable. And so we're still throwing this out of the table right now, or off the table in this case. But it does show definitely a formidable tropical storm, if not even a hurricane here, as it moves pretty much in the southeastern extent here of the Turks and Caicos Islands. Now let's take a look at the European model on its deterministic forecast. Yeah, here we go. Let's move that forward here for y'all. So if we move this forward in time into the afternoon hours, we can see that the European model does not go too aggressive initially with the intensity. We're pretty much seeing that right now. It's not really in a hurry of organizing, but with the deep convection though, this could surprise us a little bit. But right now with the European model, I'm putting a lot of weight on this model for right now. We're going to rely on this a bit. And we can see that the system really does not strengthen much over the next 24 hours and remains very anemic and rather weak here over the course of the early part of the weekend. But after that, by Saturday afternoon into the evening hours, the system really takes off here. But even so, this has not been a very straightforward forecast, and we can see this on prior European deterministic model runs. If we look at the 12Z output, we can see that the system was a little larger, taking more advantage of the upper ocean heat content, and prior runs had it a little weaker and a little stronger. So this really means a lot, but this run by itself is a lot weaker than what we initially thought, but also goes a little further to the south too at the same time, then allows the system to really take full advantage of the background environment that has very little vertical wind shear, and allows the system to really strengthen in a hurry before making that turn to the northeast directly over Puerto Rico, not Puerto Rico, excuse me, Jamaica. I want to make that clear before it makes a turn to the northeast over Jamaica in about 6 days. It takes 6 days to even get to Jamaica in the first place, versus a prior model run was a lot faster and actually showed the system hitting Jamaica a day sooner. So even timing differences here are being realized, and location differences, intensity differences. That's why this forecast is extremely complicated, and we are not going to know for certain exactly how intense this is going to get and exactly where it's headed. But we know for a fact that Melissa is going to take some advantage of the background environment, which to strengthen within over the course of the next 5 days. Now, looking at the European or the HWRF parent run, we can clearly see that happen here. Now, it is very important to note, I'm going to briefly discuss this because I don't want to make this too long of a video. Please do not trust the hurricane models right now, even so I am showing them to you, because I want to kind of school you all on this, because the initialization means everything for this system. And what I have noticed here is all of the hurricane models are initializing this in different locations, different strengths, which is not very helpful when looking at a forecast like this. And I will show you that right now briefly. So the HWRF parent run initializes the system pretty much where we think the system actually is. So not a big problem there. But if we look at the halves A model, look at where it initializes a system much further to the southeast here of where we think the system should actually be. Very close to Aruba, actually, at this present time on this run. But if we look at the halves B forecast, the system is actually located much further to the northeast over here. So we have really wild outcomes where the system or where the models initiate the system, or initialize, we should say, the system in its current location. And we don't know for a fact exactly, well, we know for a fact it's located somewhere over here, but exactly is the key point that we don't know right now. And until we get a very coherent circulation and a well-stacked vortex, this is going to change all over the place. We're going to see wild outputs from these models, some going well to the east of Jamaica, some going well to the west of Jamaica before that turn to the northeast, and some directly on top of Jamaica. We don't know yet who is going to get a direct impact of this, but we do know there is going to be a lot of heavy rainfall associated with this. All right, so what ends up happening here is on the HWRF, the system really intensifies and hits Jamaica directly in about 60 hours as a very intense hurricane here. Category 2, Category 3 intensity moving over the island, and it tries to re-intensify it a little bit more here with winds that are in the ballpark of Category 3 or 4 intensity. When we look at the halves A model similarity, the system does try to intensify, but not as appreciably like the other models here, and it really stalls and it drifts, okay? This is probably not going to be the scenario that we're going to see here, because again, initialization, timing, and everything that gets involved here is very offset from what we're actually seeing in reality. So again, right now, please use the hurricane models with caution at the present time. When you look at the halves B model, same thing. It does show a strong system, but also actually is that, yeah, that's the same model. I wanted to make sure I got that correct here in this video. The system really moves slowly and spins a couple of days over Jamaica, and I want to make it clear, I don't think that's going to happen. I think it's going to spin about a day or two over Jamaica, riding the coast, or well to the south of Jamaica, or on top of Jamaica directly, or to the northeast of Jamaica. But I don't see a system spending 2 days or even 3 days like what the halves A and the halves B is showing. That is very bad, and I just don't see it happening. I really don't in this kind of situation. So now the big real question here with Tropical Storm Melissa is, how strong will it actually get once it gets very close to Jamaica, or if it will get close at all to Jamaica or Hispaniola over the next 4 to 5 days. So when looking at the spaghetti plot here from Tropical Tidbits, you'll see all of these different plots here and different intensities, basically telling us different outcomes of how strong Melissa could get based on location. And we can still see the majority of the model guidance has actually lowered in this cycle than previous model cycles, indicating a Category 1 or a Category 2 hurricane here, with not as many showing a Category 3 or a Category 4, or even as high as a Category 5 like we had yesterday morning, as in basically Wednesday morning or Thursday morning. And because of the level of uncertainty that I'm seeing in the intensity guidance, the track guidance here, I am not too comfortable going very high at all on this. And I am remaining quite conservative with this forecast, especially when 20,000 people watch my tropical weather outlook and discussions here. I have to be a little bit more more conservative than usual here for many reasons. And because of that, my intensity forecast has not changed much in the last 24 hours or between subsequent uploads here on the channel. And I do still forecast this to become a low to mid-grade Category 3 hurricane with winds that max out between 115 to 125 miles an hour in about 3.5 to 5 days. And that's where I max things out. I am below the National Hurricane Center for this reasoning because of the level of uncertainty, and I would not be surprised if the NHC actually trends back down with their intensity forecast in the next couple of forecast packages that they release throughout the next day or two. So once again, I do forecast Melissa to become a major hurricane, but only a low-grade major hurricane with winds again between 115 to 125 miles an hour. But in the meantime, here's a look at the latest 2 a.m. Eastern Daylight Time tropical weather advisory here on Tropical Storm Melissa, and we can see the very slow movement that this system is going to be exhibiting. Very, very slow. If not, the system could stall for about a day or two somewhere in this area, or might have stalled already. We do not know about that exactly until we get recon aircraft in there, but it is not moving fast at all. And until, again, this really gets on the move or moves fast enough to where we have a pretty good idea that this track is more certain instead of it wiggling around all over the place because of erratic storm motions because of center reformations, we're really not going to have a concrete answer on exactly how close this is going to get. For that reasoning, the National Hurricane Center has a hurricane watch and a tropical storm warning out for Jamaica. All preparations need to be rushed to completion immediately just in case if the system moves directly over or just to the south of Jamaica as a formidable hurricane. And right now, Hispaniola, or the western half of there, is under a tropical storm warning and a hurricane watch at this present time. The storm, again, is only crawling very slowly at 2 miles an hour to the north with maximum sustained winds of about 45 miles per hour. But anyways, if you did find this morning's tropical weather outlook and discussion on Tropical Storm Melissa very helpful, detailed, informative, and life-saving, please don't forget to subscribe to the YouTube channel if you haven't already. Please enable all notifications on this YouTube channel to get daily tropical weather updates, discussions, including live streaming coverage on this tropical storm as it does gradually begin to organize and intensify. And also please leave a comment in the section below this video and smash that like button because we are extremely close to 60,000 subscribers, folks, all thanks to your guys' awesome support. I'll have another update on this tropical storm later on this afternoon, so please stay tuned for that.